This is the 2018 Calculus BC question number 6 FRQ. So let's read this and do this. So they give us a Maclaurin series for ln of 1 plus x. So I'm going to write that here. ln of 1 plus x is equal to this infinite series. On its interval of convergence, the series converges to ln of 1 plus x. So there's, not everywhere, but just on an interval, it does converge. Let f be the function defined by, okay, so we have a new function f. So part A, we want, I will do this right here. So part A, we want f of x, it's x ln of 1 plus x over 3. Okay, I'm going to do this in multiple parts, so let me back up on what I just wrote. So there are 5 things you can do. So if you have a function and its series, you're able to do a composition, basically replace x with a new function on both sides. So it's 1. You can multiply that function by a power of x squared, x cubed on both sides. That's legal. You can add 2 series together, subtract 2 series. You can take the derivative of the left side and right side, they're equal, and you can integrate the left side and right side. I can't remember if I got you all or if there's one that I'm missing, but basically, if you look at this function here, they first replaced all the x's with x over 3. So that's what I'm going to do first. I'm going to say ln of 1 plus x over 3. So right here on the right side, I'm going to replace all the x's with x over 3. And I don't remember how many terms it asked for, so let me double check. The first 4, so that's 3. I need one more. And then the general term, I'm going to do the same thing, replace x with x over 3. I like that. So we're almost done. I'm thinking we should simplify this next and then do our last step. So it's x over 3 minus, that'll be x squared. On the bottom, we're going to have a 2 and a 3 squared. And then it'll be x cubed. On the bottom, we're going to have a 3 and a 3 cubed. Here, we'll have x to the 4th. On the bottom, we'll have a 4 and a 3 to the 4th. Dot, dot, dot. Here, we have x to the n, and the bottom an n, and a 3 to the n. Now we want to multiply both sides by x to get f. So f of x is x times what we just have. So multiply everything by x. X squared over 3, x cubed over 2 times 3 squared, x to the 4th over 3 times 3 cubed, minus x to the 5th over 4 times 3 to the 4th, plus dot, 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 plus n plus 1. Since I'm only multiplied by x, I get an extra x, so I do plus 1, n times 3 to the n plus dot, dot, dot. That should be it. Let me double check with what they got. 2, 3 squared, 3, 3 squared, 5, 4, and the general term, n plus 1. Okay, looking beautiful. So that is part A. So part B, determine the interval of convergence. This is going to be a lot of work. I think I'm going to be okay, and I'm going to hide some stuff so I have room. Yeah, I think I'm okay here. So for the interval of convergence, 99 times out of 100, you're just going to use the ratio test. So I'm going to find a sub n plus 1 over a sub n. I'll do that first, and then I'll do the limit after that. So a sub n plus 1, I'm going to replace all the n's with n plus 1. So negative 1, the n plus 1 is going to get n plus 2. X, n plus 1 is going to be n plus 2 over n plus 1 and 3 to the n plus 1. So I just took this general term here and added 1 to all the n's. Then I divide it by that I just circled. But you multiply by the reciprocal, so you get n times 3 to the n over negative 1 to the n plus 1, x to the n plus 1, and now we start canceling. So we're going to look at the x's. If you look, the top one has an extra x because it's 1 bigger. So when you cancel those, you're left with an x. Then my 3 to the n's here and here, the bottom has 1 extra 3. So when you cancel those, you're left with a 3. Then we're going to look at the negative 1 to the powers. If you look at the top has n plus 2 of them, the bottom has n plus 1. So the top has an extra 1. So I got a negative 1. And so this simplifies all to negative 1 x n all over n plus 1 times 3. I think I got everything. So what does the ratio test tell you? In the ratio test, it tells you have this r, and you find it by taking the limit as n approaches infinity of absolute value of what we just found. Wow, that 3 is going to get in our way. Oh well. X, n, it's a different color. We're okay. 3n plus 1. And n is the one that's increasing. So x is actually a constant. X is going to be the value, see this function up here? So you might pick it to be 5. And then x stays 5 always. So x is a constant. So we're going to take the x out and the 3 out front. And then we're left with this. Whoops, daisies. Negative n over n plus 1. The absolute value, the negative disappears. That just comes out to be 1, so we're left with that. So what does the ratio test say? If r, which we just found, is less than 3, it converges. So I will say the conclusion. F of x converges on the interval, or when, I should say when the absolute value of x over 3 is less than 1. Now, that doesn't tell us everywhere it converges, because when that ratio equals 1, we don't know. So we have to test those later. We know that less than 1 works. So if I multiply both sides by 3, therefore, absolute value of x is less than 3. And if I rewrite this, therefore, we get that. So we know it converges on that interval. But we have to find out what happens at the endpoints, because at the endpoints, the r is going to equal 1. So now we have to say, what happens on the left side? Let x equal negative 3. If we plug that in to our general term, which, I erased it all. Okay, if you have it on your sheet. So I'm going to replace the x in the original function with that. And that should get me this. Negative 1 to the n plus 1. negative 3 to the n plus 1 all over n times 3 to the n. So we know that things with the same exponent, do you see that we have an n plus 1, they're the same exponent? Therefore, we can combine those, and that's going to be 3 to the n plus 1 over n times 3 to the n. Now, this is kind of cool. The top has an extra 3. That leaves a 3. I like that. It's kind of pretty. So that equals 3 over n, which is equal to 3, 1 over n. But 1 over n is harmonic. Therefore, diverges because 1 over n is harmonic. Then, wow, am I going to be able to squeeze this in? Let x equal 3. Okay, to make a long story short, if I plug a 3 here instead of a negative, we're going to get a negative 3 on top. It's going to come out to be negative 3 over n, which is negative 3, no, bad Yoshida. I can pull the 3 out. I'll take the 3 out, and negative 1 over n. Now there's a theorem that says an alternating harmonic series converges. So you could say therefore converges because it's an alternating harmonic series, or you can say this is an alternating series is an alternating series whose terms decrease in magnitude, therefore converges. And your final conclusion, therefore the interval of convergence is, so at 3 it converges, so we're going to do this. There is our interval of convergence. Beautiful. Now we're down to part C. So they want the error bound, the alternating series error bound. So again, we're going to state, since the series, okay, do I have the original series? I think I do. Since is an alternating series whose terms decrease in magnitude to 0, therefore the absolute value of the error is the next term. What's the next term? Well, which term did we go up to here? We went up to the 4th degree term. We want the 5th degree term. We never found the 5th degree term, or did we? I think we did in part A. We did. It's right here. You can see that. Let me do it in red because you're not. So we found the 5th degree term. So it's the absolute value of the next term. So it's going to be absolute value of minus x to the 5th. Absolute value of minus, what's x? X is 2, 2 to the 5th, over 4 times 3 to the 4th. 4 times 3 to the 4th. And we want, oh, they just want to find that. So this is just 2 to the 5th over 4 times 3 to the 4th. Now they actually simplified that, but you shouldn't. Yeah, that answer, you're done. But you have 5 2's on top, you have 2 2's on the bottom, so it's going to be 2 cubed. 3 to the 4th, that's 81. So it's going to be 8 over 81. We're done. Do not simplify it. Do not. Do not. That is foolish. That's it for this problem.